Hey guys, welcome to mini lesson part 2. In this part of the lesson, we're going to talk about electromagnets and metals that magnets interact with. And so this is a continuation of that first YouTube video that I posted. And so if you're missing any parts before this, you want to watch part 1. And that'll all be linked on Canvas, and I'll also share them during class. So anyway, mini lesson part 2, electromagnets and metals. So here is our last and final vocab word for this unit, and that is electromagnet, a type of magnet in which the magnetic field is produced by an electric current. And so what this is you have a piece of iron or another magnetic metal. If you wrap a wire around it, connect that wire to some kind of energy source like a battery, then that electricity from the battery or that energy will flow through the wires around that piece of metal, and that metal will create those electric forces and those electrons, energy, all of that kind of stuff is going to be transferred to the iron core or to the piece of metal. And that's what creates the magnetic field that goes around the piece of metal. And so in this way, you can really magnetize any piece of metal that has those properties. And so this is again going to go in your notes. So be sure to either screenshot this or write this down. So now on to some more examples of what these magnetic fields look like, as well as what magnetic fields look like. And so whenever you create an electromagnet, you're going to use some kind of a wire, and it's going to go in a circle. And so you have to have that electric current moving in some kind of a circular motion in order for something to be magnetized or for a magnet to naturally occur. For example, if you take the Earth is this spherical shape, right? So naturally kind of a circle in a sense. And so when you have liquid metal and liquid magma in the earth, those currents that happen within the earth's core, that carrying of liquid metal actually produces energy. And whenever that energy is going in that circular motion, it produces the magnetic field around our earth. And so that's kind of a simplified version of it, but basically, because of that circular current, the magnetic field around the earth is created, and that can be created a lot of different ways. And so with that, I am going to refer you to watch a video on YouTube. If you look up electromagnet experiment on YouTube, you can see a way that you might be able to make an electromagnet on your own. I will say that I do not condone doing this experiment without an adult present, as there is a nail involved as well as a battery that does get hot during the experiment. But there is a way to create an electromagnet on your very own, and you can magnetize a nail with this kind of phenomenon and idea. So I'll refer you to watch that on your own.
Hello.
All right, so I'm going to go ahead and skip over that. After you watch a video like that, I want to encourage you to think about what are the roles of each of the different aspects or the different materials used in the experiment. So what was the role of the battery? And then what type of energy was converted in the electromagnet, if you choose to watch the video. Okay, now on to the magnet rules. So as you know, we've already filled in magnet rule number 1 and then also number 2. Now we're moving on to 3, 4, and 5. And so what we know about magnets is that magnets always move other magnets. We know that based on the different ways they can interact, attracting or repelling. We also know that magnets move other magnets, as you can see in this little GIF here. And so what you're going to do is fill in the blanks on that third rule there. And it's going to say magnets always move other magnets. That's what your magnet rule number 3 is going to be. That kind of rhymed. So go ahead and pause this if you need to, but I'm going to go ahead and move on. Okay, so now we're going to move into the next magnet rules that have more to do what other things besides other magnets the magnets interact with. And so something important to note about magnets is that they do not interact with non-metals. And so if you look at a couple of different objects here on the screen, we have non-metals and metals. And so wood is an example of a non-metal, and so is plastic. These do not have any metal properties. whereas iron and nickel are metals that magnets interact with. And so those are important to remember as examples of things that magnets do interact with. And so magnets never move wood or nonmetals. This is your magnet rule number 4. And so this is the fill in the blank for magnet rule number 4. So magnets never move wood or nonmetals. So if you were to hover a magnet over a piece of wood, or maybe a pencil or anything like that, it is not going to be picked up by the magnet. There's no properties within the wood or the other nonmetals that would cause the magnet to have its force act on that object. Now onto magnet rule number 5, and this is the one that gets kind of interesting. And so this is that magnets sometimes move metals. This is another fill in the blank. For example, iron, nickel, and cobalt. These are examples of metals that magnets do move. Now, the interesting thing is sometimes. What does that mean? The sometimes means that not all metals interact with magnets. For example, aluminum is a non-magnetic metal, and that's because whenever you have a piece of metal, or whenever you have any object for that matter, there are different properties about that material that make it interact with things differently. And that has to do with its atoms at a molecular level. And so what I have up here on the screen is an example of what an atom would look like. You have protons, neutrons in the center, and then you have electrons floating on the outside. And so whenever you have a piece of metal, it's the same thing. You have atoms with electrons floating on the outside of each of those atoms. And so the metals that magnets do interact with have a very high concentration of those electrons. And that allows the magnetic force of the magnet, the magnetic field lines, to interact with that metal. Whereas something like aluminum has a lower concentration of those electrons, and it's not going to want to interact with the magnets as readily. And so that's why. You don't need to know that for a test or anything, but I did want to include that's the reason why. You could take a magnet, hold it over certain metals, and it's not going to do anything. Whereas if you hold a magnet over iron, nickel, or cobalt, it's definitely going to interact. And with that, that's all for mini lesson number 2. Next week, we are going to be talking about Stranger Things and identifying why those magnets fell off the fridge in a couple of episodes. And so that's what we're going to be talking about next week. If you have any questions, feel free to shoot me an email or come to office hours on Monday, and I'd be happy to work with you. Thank you guys, and I'll see you all in class. See if I can stop recording this video. Bye, guys.